Right, here's our first worked example. Aren't you excited? Here we have the case one, and we're seeing how we would actually solve a question that would have that reduction formula stuff. Here it is. It's saying use the reduction formula to find the integral of x cubed e to the x with respect to x. Straight away, you have realized that this is from our case one that says the integral of x to the n e to the x, right? Oh, so you already see, you're already going to say, well, I know that in here, my in is this one, is x to the n e to the x with respect to x. I know that. You've already found out by saying that there's an x cubed e to the x. Now the next thing you'd have to find out is, okay, if your in is of that form, what would be the formula? Here is the formula. In would therefore be equal to, we take what is inside the integral, which is x to the n e to the x, then we subtract n multiplying in minus 1. Wow, really? Yeah, that's the thing. So then we want to find for the first scenario where our I was 3, our n was 3 rather, to find this x cubed whatever, right? So you can say let n be equal to 3, right? Or you could have first shown that integral, let me write it this way, the integral of x cubed e to the x dx is equal to I3, okay? So yeah, you can say that. Then you say, what is I3? I3 would be, there's 3 for n. Everywhere there's n, you put 3. So it'll be x to the 3, e to the x, minus 3, there's an n, so you put 3 there. I to the n minus 1, our n is 3, so this becomes 3 minus 1, which is 2. Okay? Then you can find for I2, okay? I2 would be, so here would be I3, okay? And you'll be saying that n will be equal to 3. I2 here, for I2, you know that in I2, n is equal to 2. So wherever there's n, you're putting 2. So it'll be x to the 2, e to the x, minus 2, n minus 1, that's I1. Then I1 itself would be x to the n, which is x to the 1, that's just x, e to the x minus, here there's no 2 anymore, but it's now just 1, so it'll be I0. That's where you must be careful here when we are evaluating, because you can easily find yourself bringing back this 3, 3, 3, and yet it's not 3 anymore. The n goes down. As you see, this is the n. When this is 3, n is 3. When this is 2, n is 2. When this is 1, n is 1. So be careful there. Right. Now, okay, when we get to I0, things stop, because it's just something that we evaluate, okay? And how do we evaluate I0? You go to what your form is. Oh, so here, we use this original expression where we say that our in is the integral of x to the n e to the x. So that means you'd say I0 would be the integral of x to the 0 e to the x dx. And what is x to the 0? Is just 1. So that means I0 is equal to integral of e to the x dx, because 1 times e to the x is just e to the x. And that means I0 is equal to e to the x, because the integral of e to the x dx is just e to the x. You can add some small constant, but here at this point in time, we don't care about the constant. We'll put the idea of constant later, okay, in the final expression, okay, because even if we were to put a constant here and call it C1, at the end we would then add with that other final constant, and we would get a constant again, because constant times constant is still constant. Constant minus constant is still constant, so it doesn't matter. But anyway, you can put for those that want to. And now we can then write to say, what did they want? Oh, they wanted this, which was our I3. They wanted this guy. So let's put him. So that means the integral of x cubed e to the x with respect to x is equal to, what is it? It's I3, right? We said it's I3. And what is I3? It's x cubed e to the x minus 3i2. And what is I2? I2 is this stuff, okay? So we put that. So we can say the integral of x cubed e to the x with respect to x is equal to x cubed e to the x minus 3 of I2 is x squared e to the x minus 2I1. Really? Yeah. So whenever you get to a point like this, I would recommend you expand. Whenever you have things like this, expand right away. So that means if I'm expanding, I'd say x cubed e to the x with respect to x is equal to x cubed e to the x expanded. So it'll be minus 3x squared e to the x. Then minus 3 times minus 2 becomes plus 6I1. Okay? So that we don't have many brackets. Now I1 is now coming in. I1 is this expression, but it's only going to be multiplying 6. Instead of this whole 3, then another thing here again. Okay? I'm sure you get the idea. This is therefore x cubed e to the x with respect to x is equal to x cubed e to the x minus 3x squared e to the x plus 6 times, what is your I1? My I1 is x e to the x minus I0. So I1 is x e to the x minus I0. And what is your I0? Your I0 is just e to the x, but you can start by expanding first because we said expand before you put another thing. Okay, never replace inside a bracket. So we can say x cubed e to the x with respect to x is equal to x cubed e to the x minus 3x squared e to the x plus 6x e to the x minus 6I0. Because positive 6 times negative, positive, when the signs are different, you always get a negative answer. So positive 6 times negative I0 is negative. Of what? 6 times I0 is 6I0. Okay, so now what is your I0? I0 is just e to the x, okay? We don't want to add this constant of integration. See, we say don't include it right now. Although in any other case, it would be there, okay? If you're asked to just integrate this guy, you'd have to put that. But here in our reduction formula, we don't have to include it right now. So anyway, this becomes x cubed e to the x with respect to x is therefore equal to x cubed e to the x minus 3x squared e to the x plus 6x e to the x minus 6 of I0. I0 is e to the x. Wow, really? Yeah. And then, because we have done everything, you then add your constant of integration, c. Wonderful. And if you want to factor out e to the x of all these guys, it's still fine. You can write your final solution as e to the x with respect to x is equal to, I factor out the e to the x. Here I'm going to remain with x cubed. Here I remain with minus 3x squared. Here I remain with plus 6x. Here I remain with negative 6. I close my bracket plus c. This will be my final answer, and you get all your marks. Well done. So this is just how you do it. It's not very hard, is it? No, you just have to remember the reduction formula for x to the n, e to the x, and then you can apply the things. If you need to watch it again, I recommend you watch until you remember every single stage and be able to do it the right way. Okay, goodbye. Thanks for watching.